Hi, I'm Stephanie Crabtree. I'm from Prepped and Polished Tutoring. This is the second part in Matrix Math on the ACT, and this one I like to call the power of reasoning. Now that you have the skills of working with matrices from part 1, let's talk about the two types of problems that generally come up on the ACT. The first one we like to call an element comparison problem, and the second one is a matrix multiplication problem. Here's a problem I drew from an ACT. We have A times the whole matrix of 2, 6, 1, 4 equals x, 27, y, and z. And the question asks, for some real number A, what is x plus z? This looks really confusing at first, but remember, this is a line and this is a line. And what do we know about multiplying an equation, all of the elements in an equation, by a number? It's just that equation times that number. So what we can do is we can take this piece right here and we can bring A, we can distribute it into the matrix. So it's going to look like this. 2A, 6A, A, 4A, and again, this side of the equation remains unchanged. X, 27, Y, and Z. Don't get confused by these variables being called X, Y, and Z. Those are simply numbers that they decided to call names. Those are not the actual variables of the line that they are the coefficients for. Now here's where the comparison type of problem comes into play. These are lines that are matched up. They're equal to each other. So instead of trying to do some fancy solving or fancy substitution, what we're going to do is we're simply going to compare element by element. Remember, an element is one piece of the matrix. So what do we know that's completely defined? We know this 27 and we know this 6A, and we know that A is a real number. So what we're going to do is we're going to say 27 equals 6A. And we're going to solve for A, so we can use it in the rest of the problem. So A equals 27 over 6, divide top and bottom by 3, and we get 9 over 2. Okay, we're going to move to the top of the board, so I have a little more room here. We found that A is 9 halves. So what we're going to do is we're going to plug that in for one of the variables we need, which is x. And then we're going to plug in for z. So x plus z is now, element by element comparison, 2a plus 4a. And that, we're going to plug in our a of 9 halves to get 2 times 9 halves plus 4 times 9 halves. And that will equal 9 plus 18, which is 27. And 27 is our answer. Remember, this is just algebra. It's a simple way of comparing equations. And that is the sum total of what you're going to need to know for the type 1, which is comparison of elements type of problem. Here's another type of problem that we tend to see on the ACT. This is a matrix multiplication problem. Remember, we know two things about matrix multiplication. The first being it has to go in one order. So if we're looking at which product is undefined, we know that WX cannot be reversed to be XW. We have to keep it WX. The second thing we know about matrix multiplication is that we have to make sure that the number of columns equals the number of rows. So the columns in the first matrix has to equal the number of rows in the second matrix. Alright, so let's look at these answer choices here. First of all, we have a 2 by 2 matrix here. We have another one here. We have this one with 2 rows and 3 columns. And we have one with 3 rows and 2 columns. So first answer choice, WX. We're not even going to do these multiplications. We're just going to look and see if they're undefined, meaning can we not do it? Okay, So W has 2 columns and X has 2 rows. Therefore, we could multiply this row by this column, this row by that column, etc. This row by that column, this row by that column. This works out just fine, so that's a good one. All right, so now let's look at answer choice B. We again have 2 columns, and for part Y, the second matrix, we have 2 rows. We don't even have to do the multiplication to know that this also works. All right, let's go through the last 3 answer choices. Y, Z. We have 3 columns and 3 rows. That works. Answer choice D. We have 2 columns and 2 rows. Again, this works. I want you to note something. WX worked and XW worked. This was because these both had the same number of rows and columns. This is not always going to be true. Not always will you have the reverse of one operation working, only when they have the same number of rows and the same number of columns. All right, let's do the last answer choice. XZ. We note that we have 2 columns and 3 rows. We don't even have to do the multiplication to know this is not going to work. This is the answer choice. Remember, matrix multiplication and also matrix element comparison are the 2 types of problems you are going to see on the ACT. It's not likely that you'll see any addition, though we learned that in the first video, part 1, and it's certainly not going to be on the test that you'll need to solve anything with these matrices. Just remember, do a little reasoning to figure out which elements go with which elements for comparison and which rows go with which columns for matrix multiplication. With a little knowledge and a little reasoning, you'll be just fine with matrices on the ACT. If you liked this video, give us a thumbs up. And if you want more tutoring, go ahead and check us out at preppedandpolished.com.